Hello and welcome to the session. This session we will be discussing about k-means clustering. Now k-means clustering is a popular unsupervised machine learning algorithm which is used for partitioning a data set into predefined number of clusters. So we have seen there are mainly two types of machine learning algorithms, in fact three: supervised, unsupervised and reinforcement learning. So in supervised, what happens is we have the data sets with labels, but in unsupervised data sets you do not have labels, right? You just have data which is given in the data set. So the algorithm has to uh, understand the pattern behind the data and make clusters and thereby do the classification. So k-means clustering is one such important method which can be used for partitioning the data set into different clusters. Uh, the main goal of k-means clustering is to group similar data points together into one cluster, and this is done basically by understanding the underlying patterns or structures within the data. So what is important is when a cluster is formed, the data points within that cluster has to be similar to each other. So the main goal or aim of k-means clustering is to minimize the distance. So when we are applying the algorithm, when we understand the algorithm, we'll see that the main goal here is to minimize the distance between the points within a cluster. So k-means basically is also called as a centroid based algorithm, or it is also called as distance based algorithm, because we calculate the distance between the data points to a centroid. Centroid is basically the center of the cluster. So basically the distance between the data points to the centroid is calculated, and the distance is and the goal is actually trying is to minimize the distance between the centroid and the data points. So basically k-means, we can say each cluster of course will have a centroid which defines the center point of the cluster. Now the main objective of k-means algorithm is to minimize the distance, sum of the distances between the points and their respective cluster centroid. So optimization is a very important here. What is the goal of optimization is we have to find the best set of centroids that will minimize the sum of the squared distance between each data point and its closest centroid. So let's understand this with an algorithm. Um let's take an example. Let's say the bank only wants to use income and debt in order to make the segmentation. So on the x-axis, this figure 1 shows the original data. This is the original data set, where on the x-axis we have the income and on the y-axis we have the debt. So this is the scatter plot of the original data. Now let's try to make clusters or apply k-means algorithm on this original data. So as a human, you can easily say that these data points here can be made into one cluster since they are all very close to each other. These data points here can be made into one cluster. This can be one cluster and this is one cluster. Now how did I say that? Because visually what I am doing is I am trying to group together data points which are near to each other, and therefore I make a cluster. So similarly, if I apply here k-means clustering, right, this kind of a segmentation would be done, or this kind of a clustering would be done, right, should be done. So these are the different clusters that are actually formed. So basically when you're working in k-means algorithm, basically how it works is a centroid is defined. So centroid is basically the center of a cluster, and then the distance between the centroid to each data point will be calculated, and keeping the goal as to minimize the distance. The goal is to minimize the distance from the centroid of a cluster to the data points. The clusters are formed. So the main property of k-means clustering algorithm is all the data points within a cluster should be similar to each other, and the data points from different clusters has to be different, should be as different as possible, right? So if you look at this figure, so what do you mean is this is one cluster. All the data points within a cluster has to be very similar to each other, but it should be very different from the data points of another cluster. Now there are two cases here, case 1 and case 2. Looking at this, can you tell which clustering is better? See, the data points are same. We have not changed the original data points. It is same as before. The data points remains as same, but the way of clustering is done is different. So what you observe in case 1 is the customers in the red and the customers in the blue, they're quite similar to each other, and therefore what happens is there is an overlapping of the cluster here. But what you see in the case 2 is the points in the red cluster are very different from the points in the other clusters. So looking at this, we can actually say that, right, the case 2 is a better case of clustering. Now coming to the algorithm, how it works. First step is to choose the number of clusters k. So we have the first step in the clustering algorithm is you have to choose the number of clusters that you have to form before itself. So choosing the number of k, that is the number of clusters. So let's say this is the original data. You have to decide how many clusters you need to make. Then you select k random points from this data as centroid. Next, after choosing k, you have to choose a centroid. So this is the original data. Suppose I have taken k as 2. So that is number of clusters as 2. Then definitely there should be 2 centroids. Let's say C1 and C2. So any point here in this, don't worry about where you're going to put the centroid. Just choose any 2 points to make the clusters. Okay, so let's say I have taken this as cluster 1 and this as cluster 2. That's what done here. This is the points are same as this. The only thing is in the step 2, now I am defining the centroid. Okay, so I have randomly selected the centroids. I have taken 2 centroids because in the first step I have chosen k as 2. Every cluster will have one centroid which defines the center of the, it should be the center of the cluster at the end. So we have chosen different colors to differentiate between the 2 clusters. Now in the step 3, we are going to assign the points which are very close to the cluster centroid. Okay, now this is C1. So what we do is we choose the points which are close to C1, right? So let's say this and this data point are chosen. So basically how it is done is the distance. We will see a mathematical way of doing this is in another session. The link will be given in the description box. So basically what is done in the algorithm is the distance between every point, every data point will be calculated with respect to the centroid. And the goal is the data point which has minimum distance to that centroid will belong to that cluster. So looking at this, after doing the calculations, you will see that the distance from here to here or here to here or here to here will be less as compared to the distance of this data point with respect to C1. So this data point is closer to C2 and not C1. And therefore, this is one cluster, this is another cluster. Next, in step 4, we recompute the centroids again because the centroid we chosen was just we just made a assumption and choose before. So now we have to change the centroid. So how do you change the centroid? So when you're changing the centroid, of course, the calculations are done again, the distances, right? Once we have assigned all the points to each cluster, now we recompute the centroids, right? So after recomputation, you can see that the red and green crosses are the new centroids. And in step, again, you repeat this process. It is an iteration. So you repeat the step 3 and step 4. You form the centroids again you find out the distance. Whichever is minimum to every data point, that would be taken as a cluster, right? So the step 3 and 4 will be repeating. You recompute the centroid again, right? And then again recompute the distance from the centroid to the data points. Whichever is minimum, that would belong to that centroid. That data point will belong to that centroid. So this step 3 and 4 will be repeating. So the next question is how long, right? What is the stopping criteria for k-means clustering? So how long the iteration is done? How long step 3 and 4 will be repeated? So basically there are 3 stopping criteria. Maybe you can define the maximum number of repetitions or iterations in your algorithm. Or even before reaching the maximum number of iterations, suppose the centroids are not moving. right? The centroids of the newly formed clusters, they do not change anymore, then that can also become a stopping criteria. Or maybe the points will remain in the same cluster, so the points are not changing, the data points are remaining in the same cluster, that can also become a stopping criteria. So let's see how we can implement k-means clustering in Python. So let's take a problem of an wholesale customer segmentation problem. The link for the data set, I'll give it in the description box. The data which were taken is from a UCI machine learning repository. The goal of this problem here is we are going to segment the clients of a wholesale distributor based upon their annual spendings on diverse products like milk, grocery region, etc. So let's go to the collab. Okay, so what we are doing here is, so this is our code, right? So I have already I'm not going to depths of how this code is going to work. I will just show the results, and we'll just have an overall discussion of how k-means clustering should be or should look like. So let's say this is the data. So I have downloaded a CSV file, and when I write here, so this is the pandas, right? I'm reading the CSV file, and if you just want to see some of the first rows of the data, you just have to say data dot head. So this is how some part of the data set looks like. Okay, so this is a different example. Okay, this is a different example where I have taken some, this is a CSV file where I have information about the loan ID, gender, married, dependents, education, self-employment, application details, loan amount, and all this. Okay, so basically you have to say that whether the loan will be approved or not based upon all these details. So loan is yes, loan status is yes or no. So let's first plot the original data. So this is how the original data looks like. Okay, so this is how the original data looks like, and for plotting the original data, we have so many components in the y-axis. I'm not plotting or not taking anything. I'm just taking the loan amount in the x-axis and applicant income in the y-axis. Okay, so this applicant income will be in the y-axis, and loan amount which we is asking will be taken into consideration. So this is the loan amount in the y-axis and the annual income that he is receiving in the x-axis. So this is how the data point looks like. Now let's choose the number of clusters, right? So let's say so let's, as I told you, the initial step is you have to choose, right? So let's say I choose a number of clusters as 3. So basically, and then I'm going to select the random observation as centroids. Okay, so I've done step 1 and step 2 in this part of the code, where we have chosen the number of clusters as 3, and randomly this is in this part of the code we are randomly choosing an observation as centroid. Okay, so there is nothing like a bias, any one point. So that's why we are calling x dot sample n is equal to say any one point will be taken as a centroid. So that means each time the execution is different, each time different centroids will be taken. So as of now in this execution, this is one centroid, this is another centroid, this is another centroid, because we have 3 clusters. Now the red dot basically represents the 3 centroids. Now what we are going to do is we are going to do the next 3 steps, steps 3, 4 and 5. Step 3, where we assign all the points to the closest cluster centroid, and in step 4 we recompute the centroids again for the newly formed clusters, and we keep repeating 3 and 4, right? So that is what is done in this part of the code. I'm not going to explain basically how the code works. So we are just seeing that the step 3 and 4 is done in this row, right? So we are assigning the points to the closest cluster centroid, that is a step 3, and then again we recompute the centroids, and again we repeat. So that's why we have a while loop here, and the condition is how long it's going to repeat. So basically again we have given a so the values will vary. As I told you, the values will vary, the centroids will vary, the clusters will vary, because initially where I'm going to have the centroids, now that will be different, right? Because it is randomly chosen, and this will keep repeating, right? The loop will keep repeating until we reach the stopping criteria. The stopping criteria can be till the maximum value, or before the or until the clusters do not change. So once that is done, right? Once the steps 3 and 4 is executed, it is already executed. So once step 3 and 4 is executed, now I'm going to plot it, right? So I'm going to plot it to see the clusters, and now you can see after the iteration has been done, after the stopping criteria has been met, this is how the three clusters are formed. So this is one cluster, blue color, cyan color is another cluster, green is another cluster, and this red data points are the centroids that we have got. Okay, so basically you can see this is how the clustering has been done. And in this, the stopping criteria is, we have given a stopping criteria where it once the you define the maximum number of iterations that you want, but before that, if the centroid is not changing, it should be able to start, or if before that the data points are not moving from one cluster to another cluster, that can also become a stopping criteria. Okay, now coming to the next problem, uh, the next question is, how do you choose the value of k? This is a very important question. So we can because for that we can go for a method called as elbow method. So elbow method can be used to choose the number of the value of k, or the number of clusters. In the Python program which I just showed, randomly I had taken k is equal to 3. But in your original problem, how do you choose k? So that you can use, for that as a solution, you can go for elbow method. So what is elbow method is, you have on the x-axis, we will do a graph, okay? X-axis will show the number of clusters, y-axis would be any performance that you are measuring. In this case, let's say inertia. Okay, so what we do is, let's start, when you are doing this in real time, let's start with a smaller cluster value, say 2. Okay, now for 2, you find out the performance what you're doing. Then you just carry out your machine learning process, choose the number of clusters as 2 and measure the performance. And let's say inertia is a performance that I'm measuring, I'm getting the inertia as 1000. Now what you do, repeat it, change the cluster to 3 or 4. So what you have done here is, when I change the value of cluster to 4, I got the inertia as 200. Then when I increase the cluster as 6, I got the inertia is 100. So as I'm going on increasing the number of clusters, I can see the inertia is going on decreasing. So now again, from this graph, how can I decide which is a stopping criteria? You can see here somewhere it is becoming, this is more like a, you have to see where the value becomes actually almost constant. Okay, so the decrease in you can see the inertia is decreasing, and finally somewhere it is becoming constant, right? So the main place where I'm going to choose that this is going to be the point, then that would be based upon the elbow. So you can see in this figure, this is the elbow. So this curve looks more like an elbow, right? So this point, that is the elbow point, is over here. So we are going to choose this point as the k value, or the number of clusters. So for this example, k is equal to 4 would be the ideal value, okay, based upon the elbow method. So this is looking like an elbow, right? So k is equal to 4 can be chosen as your k value, or the number of clusters. But some things you have to keep in mind is, as you go on increasing the number of clusters, the computation cost will increase. But if you also have lesser number of clusters, then you will not really get a good clustering. So that can also be there. So what are the challenges in k-means clustering is, the first challenge in k-means clustering is finding the optimal k value. So for that, I just suggested that you can go for elbow method. But you need to keep in mind, a smaller k value will result under cluster data, a larger k value can cause over clustering. The second challenge in k-means clustering is the size of the clusters, right? So this is the original data point, and here is the clustering after k-means. What you observe here is the size of the clusters are very different, right? See, the leftmost cluster and the rightmost cluster, they are almost of the same size, but this red one is little different. So that can be a challenge. The third challenge is the density, right? The points, as you can see here, this is the original data. This is the k-means. This is after k-means clustering. See, looking at the original data, you will feel that this has to be one cluster, this has to be one, this has to be one. But after k-means clustering, what has happened here is, this has become one cluster, this has become one, and I have chosen k is equal to 3, right? This has become one cluster. So the density, why did this happen, is because of the densities. When the densities are not different, when the densities are very different, then k-means using k-means clustering becomes a problem. It may not do clustering in the way that it is expected to. The fourth challenging is when you have very large data sets, also K-means clustering is not preferable. So conclusion, what I would like to conclude is K-means clustering is a unsupervised learning method. It will help you in grouping unlabeled data into clusters based on similarity. It involves assigning data points to the nearest centroid, and iteratively it works until you have a refined cluster. Basically, the goal here is to minimize the distance between the data points and their respective cluster centers. An elbow method is one of the solutions to find the optimum number of clusters in the K-means algorithm. However, if the size of data set increases, the computational cost will increase. So in such cases, when we have extremely large data sets, it's better that you go for alternative algorithm, and one such algorithm is Gaussian mixture model, which we have discussed in another video, where the clustering can be used when you have extremely large data sets. So thank you so much. That was about K-means algorithm. In another video, I will be mathematically will try to solve one of the K-means algorithm problem. Thank you so much, and please subscribe to the channel, and any comments please write to me in the comment box. Thank you so much.